Hey guys, let's take a look at 3.5, solving polynomial equations, part 1. So we're going to solve the first set of equations here, which I think we are not too bad at. I'm going to add 5 to the other side, divide by 3 on both sides, so I get 5/3 for my x. The nicest thing is I can check my answer. I can see, is it true? 3 times 5/3 in the place of my x minus 5, does that actually equal 0 or not? And let's see, the 3's divide out. I've got 5 minus 5 does equal 0. So yes, I can check my answer. On number 2 here, it's a little more complicated. I have an x squared and a plain x. They're not like terms, so I cannot combine them. I need to factor instead. So what multiplies to be 18 and adds up to a -9? Let's see, I'm thinking both negative numbers, probably a -6 times -3 is -18. And -6 plus -3 is a -9 for my middle term there. All right, so we factored and we set individual factors equal to 0. All right, so when my first factor is equal to 0, I'm going to add 6 on both sides. Looks like x equals 6. And then on my second factor, if I add 3 to both sides, it looks like x equals 3. I do have 2 answers instead of 1. I can still check and make sure. So I can see if instead of x squared is 6 squared, minus 9 times 6 plus 18, oops, there we go. Let's see if that actually equals 0 or not. All right. And here's where we're at. My 36 or minus 54 and plus 18. All right, that does in fact equal 0. We're going to check the 3 as well. Instead of x squared, I'm doing 3 squared, and then minus 9 instead of x, minus 9 times 3, and plus 18. Let's see if this actually equals 0, and it does. So both are solutions. So I'm going to kind of start skipping this last step where I check my solutions. I still think you guys should do it, especially on a test. But even homework, kind of practice checking your answers. It does take a bit of time here, so I am gonna kind of skip this step for a little bit here. On number 3, as far as factoring goes, I know I've got a factor, but I'm gonna start with a GCF, a greatest common factor. These are all even numbers, so I'm gonna factor out a 2, and I also notice that they all have an x, so I'll factor out a 2x. 2 divided by 2 is 1, so I could get a 1x squared. I don't really need to write the 1 though. I could just call it plain x squared. And then -12 divided by 2 is a -6. So I get -6x. Again, I took out one of those 2 x's. And then here, my 18 divided by 2 is 9. And I took out that 1 and only x. So there are no more x's left. All right, so at this point, I'm kind of where I was on number 2, where I had this x squared, plain x, and a constant. So I'm going to try to factor that the way I did number 2 here. What multiplies to be my last number, 9, and adds up to the middle number, -6. All right, so I'm thinking a 3 and a 3. Either both positive or both negative are going to multiply to be a +9. And don't forget your 2x out front. It still all equals 0. And then I'm thinking -3 times -3. Negative times negative is positive, so I get my +9. -3 and -3 add up to a -6, so both are taken care of. All right, so now I will do kind of what I did before. I'm going to set each of my factors equal to 0. So 2x is equal to 0, x minus 3 is equal to 0. In fact, I've got 2 of the x minus 3's. I don't need to solve the same equation twice. I'm just going to do the x minus 3 equals 0 just once. All right, so I'm going to solve for x here, divide by 2 on both sides, x equals 0. If I add 3 on both sides here, I get x equals 3. Okay, so it looks like I got 2 solutions, 0 and 3. And again, I still suggest that you check your answers to make sure that both of those solutions work. Okay, so we have solved those equations, but then we get to these ones, which are a bit more complicated. This is not an x squared and then a plain x. This is an x to the 3rd. And it just doesn't have the layout that my previous ones do. So the stuff in the box says solutions of the equation f of x equals 0, which here's my f of x, here's my function that's equal to 0. When f of x is a polynomial with integer coefficients, my integers are these nice pretty whole numbers 1, -3, -2, those are my integer coefficients. We're gonna do p over q. So the factor of the constant term, my p, is -2 in this case. And the q is the leading coefficient. So in this case, a 1 is my q. I'm gonna do the factors of -2 over the factors of 1. Okay. So the nice thing is factors of -2 are either let's put a plus or minus here. It could be positive or negative, 1 or 2 though. It's prime number, only 1 and 2 go into 2. And when my q is 1, the only number that goes into 1 evenly is 1. So those are bringing on, let's see, how many options? 1 divided by 1 is 1. 2 divided by 1 is 2. You can either have a positive or -1 or a positive or -2. I've got 4 different options. So let's check these options and see which ones work. The instructions are the same, by the way. It's still asking us to solve. We're still trying to solve for x here. I'm going to check these options. They are not all totally solutions. They are things for me to check. So I'll check like my positive one and for my x. So there's like my x cubed, positive 1 cubed, minus 3 times my positive 1, so 3 times x, and then minus 2. Okay, that did not equal 0. This is supposed to equal 0. So the positive 1 is out. Let's check our -1. Actually, I'm going to move on to the 2 first, just because it's a little easier here. So these 1s that I plugged in for my x, I'm going to change those into a 2 that I'm subbing in for my x. Oh, that did equal 0. Okay, so I have one of my solutions. So next, that means let's factor out. Gotta have a x minus 2 has to be one of my factors. I'm not sure what the rest are right now, but I do know that if a positive 2 factors out, positive 2 minus 2 is 0, so it gives me an x minus 2. Okay, let's see if we can kind of fill in this blank right here. Let's do some division. Okay, there we go. So I'm going to do some synthetic division with this 2 that I found works. I've got a 1x cubed. I don't have any x squareds. I've got a -3x and a -2. Okay, so I'm pretty sure this remainder right here is going to be 0, but I need to figure out what the rest of it is right here. So I'm going to bring down the 1. 2 times 1, the number in the box, times the number below the line. So 2 times 1 is 2. And then I add straight down. So 0 plus 2 is 2. I'm going to repeat. 2 times 2, I multiply by what's in the box. 2 times 2 is 4. And I add straight down. -3 plus 4 is 1. Multiply by what's in the box. 1 times 2 is 2. And I add straight down. -2 plus 2 is 0, which I kind of knew it was going to be 0. But I needed the rest of the stuff, which I started with an x cubed. This was like my 1x cubed, 0 of the x squareds, a plain x and a constant. So I divided out one of my x's though. I took out this plain x. So I'm going to knock these powers all down by 1. So this is going to be a 1x squared. This is a 2x and a constant of 1. So here's what I mean. That tells me in the parentheses here that I wasn't sure of yet. That's what I'm going to get from down here, a 1x squared, 2x plus 1. Okay. Now at this point, I can actually factor. I can look at what multiplies to be 1 and adds up to 2. I'm thinking 1 times 1, 1 plus 1 gives me the 2. Okay, so I'm thinking a 1 and a 1, which means I'm going to factor this into x plus 1 and x plus 1. All equals 0. All right. So I'm at the point where I was in the last few problems where I set my factors equal to 0. And again, I have the same factor multiple times, so I might as well just do it once. This first factor, if I add 2 on both sides, 0 plus 2 is 2. All right, and the next factor, if I subtract 1 from both sides, 0 minus 1 is negative 1. Okay, so it looks like I have 2 solutions. Again, I suggest you check your answers, make sure those work in the original problem. All right, number 5, let's try this again. I got this whole x cubed thing. I don't see a GCF on any of these. And as far as factor by grouping goes, I don't think the factor by grouping necessarily works here. So I've got to try this other option, which is not my favorite, but it works. I give all the possible zeros. So possible solutions here. I do the factors of, let's see, my 1 here, that's my q. And then the p is my constant at the end here. So p is a 20. All right, so I'm gonna have a few more options this time. Factors of the constant term, factors of p. In this case, my factors of 20 are gonna give me, let's see, 1 times 20 is 20. I've got 2 times 10 is 20, maybe 4 times 5. Okay, these are all my options. And then in the denominator, the q, factors of q, well, my q is 1, so again, it's just like the factors of 1, which means all options are 1 over 1 is 1, 20 over 1. So 20, all these are just divided by 1. Okay. So these are all possibilities, a positive or negative of each. So let's say 1, 2, 3, 4, 5, 6. Looks like I got a total of 12 options. The other one over here, all I had were 4 possibilities. So I definitely have more possibilities. It's going to take a sec to check out and see which ones work and which ones don't. But I can put that in my calculator. All right, so I'm going to start plugging some numbers in here. I'm going to do my x cubed. Again, in this case, I'm plugging a 1 in for the x. So 1 cubed minus 8 times my 1 squared instead of my x squared plus 11 times 1 instead of 11 times x. And then plus 20. I want to see, does this actually equal 0 or not? It does not. Okay, so the positive 1 is out. Let's try something else. We had a positive 2 in our list. Maybe I'll go try a 2 in for all the x's instead of a 1. I got to put this in for all of the x's. All right, 18. It went down a little bit, but still doesn't entirely work. It's supposed to end up equaling 0 if it's actually a solution. So let's see, I had a 1, a 2, not a 3 was in my list, but 4 was in my list. Maybe I'll try a 4. This is kind of a trial and error setup here, which is why it's not my favorite, but if I'm not sure how else to do it, then this works. Oh, the 4 actually gave me a 0. Nice. Okay. So that means I've got to have an x minus 4 because it was a positive 4 that worked. So like positive 4 minus 4 is 0. That's how I can tell the factor. I'm not sure what else goes in there. Like x minus 4 times what gives me 0. So this is where I'm going to do my synthetic division again. Again, it was the 4 that worked. I'm going to put that 4 in my synthetic division. I've got a 1x cubed, a negative 8x squared, 11x, and 20. All right, the remainder should end up being 0. If I don't get a 0 right here, I know something's a little off. So I'm going to do my synthetic division, bring down the first number, multiply by what's in the box. So 1 times 4 is 4. and then I add straight down. -8 plus 4 is a -4. Multiply by what's in the box. So -4 times +4 is a -16. All right. Then I add straight down for a -5. Multiply by what's in the box. -5 times 4 is a -20. And I add straight down for a 0. Good, that 0 is where I thought it should be. So again, this was a highest exponent of 3. It started at x cubed and hit every exponent on the way down. And my constant. This one, since I factored out one of my x's right here, that means I'm going to take all these exponents down. So I got an x squared, a plain x, and then my constant. So this stuff down here, this is going to be what goes in my last set of parentheses here, 1x squared, which I don't need to write the 1, -4x, and a -5. Okay. So at this point with the quadratic, I think we can factor that. Anything that multiplies to be a -5 and adds up to -4, I'm thinking maybe -5 and +1. Now the nice thing is, that would give me zeros of 5 and -1, which actually were in my list already. So they actually were options. I could have chosen any of these 3 options and made it work. All right, so I'm going to set each of my factors equal to 0. All right, looks like x equals a +4, which I think we kind of already found out. That's where this +4 came from. X equals a +5 and x equals a -1. So I actually have 3 solutions. And again, I still suggest plugging those x's in to kind of check your answer. Plug them into this original problem, see if it actually equals 0 or not. Okay, so here's how you can do kind of the guessing game here. And the last little bit here are the graphs. Find the zeros of each function and then sketch the graph. If you're going to find the zeros, you have to factor it and set your factors equal to 0. On the problem number 6, I'm thinking I'd probably start with factor by grouping, if possible. Let's see, my factor by grouping, 3 times 3 is 9. Is there anything that multiplies to be 9 and adds up to 6, to negative 6, excuse me. So I'm thinking the 3's kind of already gave it to me. -3 times -3 is a +9. -3 plus -3 is the -6. So I think I kind of already broke this up into a -3x squared and a -3x squared. The first and last have not been changed. I still have 3x to the 4th at the beginning, still adding a 3 at the end. All right, so I'm going to now do my groups here. My first group, their GCF, their greatest common factor, it looks like they have a 3 in common, and the most x's I can factor out is an x squared. And I'd be left with x squared minus 1. In my second group, I can factor a 3 out of everything. In fact, I think I might factor out a -3 out of everything. All right, so I'm hoping that the stuff in the parentheses will match, which is why I think I want to factor out a -3 instead of a +3. So that gives me a +x squared and then -1. If I factored out a +3 here, I would have been kind of off by a negative sign on that. So I wanted these in the parentheses to totally match, which they do now. So I can factor out, again, their GCF. What they have in common is the x squared minus 1. And the other stuff that was not the x squared minus 1, I've got a 3x squared minus 3. All right. So I'm going to try to find the zeros. I want to find the zeros by setting my factors equal to 0. All right, so I'm going to solve this first one here. If I add 1 on both sides, 0 plus 1 is 1. Take a square root on both sides. And when I do a square root, I get a plus or minus. I get square root of 1 is 1, so a positive or -1. And then if I solve my next one, I'm going to add 3 on both sides. 0 plus 3 is 3. Divide by 3 on both sides. So 3 divided by 3 is 1. I'm kind of where I was before. I now have to take a square root on both sides. And the square root of 1 is either positive or -1. So I actually have the same options. It doesn't, it kind of tells me I've got 2 x-intercepts. The zeros are basically the x-intercepts on my graph. And they're going to be at a +1 Zoom in here. Positive 1 and negative 1. That's where my zeros should be. Also, I think we've talked about end behavior before. This was a degree 4 polynomial, like the highest exponent is 4. So both ends should either be facing up or both ends facing down. And it'll do some like curving around in the middle. But because this is a positive 3 in front of my x to the 4th, I should have both ends facing up. Okay, so let's see here. Both ends facing up. What else? Let's see about an x-intercept. My x-intercept, or sorry, not x-intercept, I mean a y-intercept. We already have our x-intercepts. My y-intercept. All right, my y-intercept is when x's are 0. So if I make all the x's here 0, I get 3 times 0 to the 4th minus 6 times 0 squared plus 3, 0 minus 0 plus 3. It actually gives me a positive 3. So the 0.03 should be my y-intercept. So I'm going to plot that on my graph here. 0, positive 3 right there. All right. Also, I think we've talked about how your positive 1, see I got one of my positive 1s, another positive 1. It had a multiplicity of 2. I got 2 of the positive 1s, which 2 is an even number. So I should bounce off of my positive 1. Okay, got my end behavior going up. Same thing for the negative 1. The negative 1 and negative 1, I got negative 1 happens twice, which is an even multiplicity. 2 times 2 is even. So I should bounce off of that. Okay, so here is what my graph is looking like. Let's check and see if that's what it looks like. I'm going to take my little graphing calculator here. And let's see. If I had a 3 x to the 4th minus 6 x squared and plus 3. Let's graph this and see what it looks like. Oh yes, looks very similar. Okay, so negative 1 and positive 1 just kind of bounced off there, hit its y-intercept up at 3. So yeah, looking very similar to this. All right, so last one. We're going to do pretty much the same thing. I'm going to factor as best I can. And I actually think I do have a GCF on this one. My GCF is an x. So if I factor out that x, I've got an x squared plus x minus 6 left. And then if I factor this, what multiplies to be a negative 6 and adds up to a positive 1? Let's see, I'm thinking positive 3 and negative 2. Let's check this out. Positive 3 times negative 2 is a negative 6, all right? And positive 3 plus a negative 2, or in other words, positive 3 minus 2, is a positive 1, which they didn't write a 1 right here, but that is a 1x. So I think we factored it correctly, which means let's set each of these equal to 0. All right, this one's already solved, x equals 0. On the second one, I'm going to subtract 3 on both sides, so I get a negative 3. On the third one here, I'm going to add 2 on both sides, so x equals a positive 2. So those should be the points that I see on my graph. I should see points at 0 and see negative 3 and positive 2. All right, so let's figure out, are we going to touch or cross those? What does the end behavior look like? All this kind of stuff. Now, since each of these factors, here's my factored section, each of those only happened once. So I'm thinking I'm going to cross. Again, over here, the stuff that happened twice, any even number of times made me bounce off of that particular point, that particular x-intercept. These ones only happen once each, which number 1 is an odd number. As long as it happens some odd number of times, it will go through the x-axis at those points. But let's figure out if I'm going to go through the x-axis like this. Oops. Am I going to look something like this? Or am I going to do exact opposite direction like this? What's the end behavior got to do? Okay, so the end behavior, because this is a degree 3 polynomial. Degree is your highest exponent. So degree 3 with a positive 1 x cubed, like it's a positive and odd degree. So your odd degrees were split. It was either like this or like this. And then this was if I had a positive leading coefficient versus a negative leading coefficient. I've got a positive 1 here. So I've got to have my end behavior doing like that top one, that left end is going down, right end is going up. All right, so down, like I said, I'm crossing through each of these. Okay, so I've got to cross through the first one. I already have my y-intercept, so I don't need to find that. It's at 0, 0. Cross through that guy and cross through the next one. I crossed through all of them, did not just touch, but cross through it. And there we go.